Hello all, welcome to my channel Simple Concepts by DJ. Today we will be discussing about some problems that is related to application of integrals. The first problem is find the area enclosed by the circle, enclosed by the circle. They have given the circle equation as x squared plus y squared is equal to a squared. So this is the circle equation they have given. So we need to find the area that is being enclosed by the circle. We need to find the area within the circle. So they have given the equation of the circle as x squared plus y squared is equal to a squared. Right. So I'll draw the diagram first. See, this is the axis. The circle will be like this, right? The circle will be like this. The circle is symmetrical about the x and y axis. X axis and this one is y axis. Okay, now what I'm going to do is I'm going to mark this point as origin O. Origin O will be having the coordinate 0, 0. This point is named as capital A, and this point is named as capital A. Okay, so if this is 0, 0 and this coordinate will be A, 0. The coordinate at A will be A, 0, right? So which means that the length of this portion is A. The length of this portion is A. So now I am going to consider a vertical strip. Okay, this is the vertical strip, and I am interested to find the area of this entire region that has been enclosed by this circle. So now this is the origin, this is the point A. Now I am considering a vertical strip over here, and let the length of the vertical strip be y. Okay, let's assume the length of the vertical strip as y, and the breadth of the vertical strip, I am extending it for visibility. The breadth of the vertical strip will be dx. Okay, the length of the vertical strip is y and the breadth of the vertical strip is dx. So now first I'm going to find the area of this vertical strip. Then after finding the area of the vertical strip, I'm going to find the area, area of this region. This is that is OA. This point I'm naming it as B. So OABO will be a region that has been bounded by this half circle. I mean the quarter circle. Okay. So I'm going to find the area of this part. And once I find the area of this part, I'm going to multiply it with 4. So because 4 different regions are there. When I multiply by 4 with the existing answer, with the current result, I'll be able to get the area of this entire region. Area of this entire region that has been bounded by this circle. Right? So now what I'm going to do is, I'm going to find the area of this vertical strip. Now I'm going to rub this one and we'll start with solving the problem. Okay, so I'll rub it off. So our given circle equation is x squared plus y squared is equal to a squared. Right? This is the circle equation. So now, again, this is the axis. This one is the circle. This is the axis. This one is the circle. And this is the vertical strip which we are considering. So this is origin point O. This is point A, this is point B. This is 0 comma 0, this one is A comma 0, right? So the length of the strip is Y and the breadth is dx. So now I'm going to find the area of this vertical strip. So for finding the area of the vertical strip, area of the strip will be equal to length into breadth, which is y into dx. Right? This is y into dx. Now I want to find the area of this region, that is O A B O. So area of the region O A B O will be, I can move this in order to find the area of this region. I can move the vertical strip from here to here, that is from 0 in the x-axis to the point A in the x-axis. So what I want to do is, if I want to find the area of this entire region, that is OABO, I need to integrate the area of the strip, that is y into dx, that ranging from 0 to A, by fixing the limits from 0 to A. So the area of the region OABO can be found out by 0 to A integral y into dx. Right? So what is y? What is the value of y? See, we know the circle equation as x squared plus y squared equal to a squared. So what will be y? Y squared is equal to a squared minus x squared, and y will be root of, that is plus or minus root of a squared minus x squared. Since we are looking into the first quadrant, in first quadrant all are positive. So if all are positive, I don't want to take negative sign, I'll take only plus. So y takes the value of plus root of a squared minus x squared. So this is the value of y. This will be the value of y. So I will substitute this value in place of y. I'll substitute this value in place of y in this integral. So my y value will be integral of 0 to a, y is root of a squared minus x squared, which is root of a squared minus x squared into dx. So I'll be getting as 0 to a root of a squared minus x squared into dx. Right? We have another formula, integral formula, as integral tends from integral root of a squared minus x squared into dx is nothing but x by 2 into root of a squared minus x squared plus a squared by 2 into sine inverse of x divided by a plus c. This is the integration formula which we are going to substitute in this parameter. Okay, so I am using this formula over here. So I'll be getting as integral tends from this 0 to, sorry. So integral tends from 0 to a root of a squared minus x squared into dx will be x by 2 into root of a squared minus x squared plus a squared divided by 2 sine power minus 1 or sine inverse x by a plus c, and I am fixing the limits from 0 to a over here, 0 to a. Okay, so now what I'm going to do is that I'm going to substitute a in place of x, and in the other part of the expression I'm going to substitute 0 in place of x. So what will happen is If I substitute a in terms of x, it will be a by 2 root of a squared minus a squared plus a squared divided by 2 into sine inverse of a by a. This is one part of the expression. The expression is over. Now I am going to substitute 0 in place of x. So if I substitute 0 in place of x, 0 by 2 will be infinity. So this will become void. Similarly, if I take 0 and I substitute over here, 0 by a is infinity. 0 by a is infinity. So sine inverse of infinity. So this also will become void. So I'm not going to continue with the second expression over here. So for me, this first expression itself is over. Okay, this will suffice. Now what am I going to do is, I'm here a squared minus a squared 0. So this won't work. Now a square, I'm being left with only one term, that is a squared by 2 sine inverse of a by a, which is nothing but a squared. I'm left out with a squared by 2 sine inverse of a by a is 1. So sine inverse of 1. This is what I am left out with. So what is sine inverse of 1? Sine inverse of 1 is 90. Sine 90 degree is 1. So it will be pi by 2. So this is a squared divided by 2, or else I'll write over here if it's not visible. See, a squared divided by 2, sine inverse of 1 will be pi by 2. Sine 90 is pi by 2. So into pi divided by 2. So I'll be getting as pi into a squared divided by 4. So this pi into a squared divided by 4 is the area of this region OABO. But we are interested to find the for the region enclosed by the entire circle. As of now, the circle has 4 quadrants. So if I want to know the area of this entire circle, and the circle is having 4 quadrants, so what I can do is I can multiply by 4 in order to get the entire region that is being bounded by the circle. So if I multiply by 4, 4 gets cancelled. I'll be left out with the answer as pi a squared. This is the final result, right? So this is what is this is the area enclosed by the circle. The second case will be, I am having the vertical strip over here. Instead of vertical strip, if I happen to use a strip like this, I am using a horizontal strip and I am measuring the area of the region bounded by the circle. I'll be getting the same value, but this looks somewhat different. Some amendments will be there. That also we'll see in case number 2, right? So let's get into the case number 2. So getting into the case number 2, see here the circle equation is x squared plus y squared equal to a squared. Now again I'm drawing the axis over here. The circle is like this. Now this point is 0, this is A, this one is B, right? So now what I'm going to do is, I'm going to consider a horizontal strip. A horizontal strip here. In the previous case, I considered a vertical strip which had an area of y into dx. Now I'm considering a horizontal strip which is capable of moving from the point 0 to the point B. Okay, so what I'm going to do is, this point will be 0 comma 0 and this part will be 0 comma a. This one is 0 comma 0 and this b coordinate will be 0 comma a, right? So this horizontal strip can move from 0 to b. So if it moves from 0 to b, I'll be able to find the area of this region, that is OABO. So let the length of the horizontal strip be x and the breadth of the horizontal strip be y. I mean y means dy. Dy is a small measurement that is used to measure the breadth of the horizontal strip. You got it. Now what I'm going to do is, as usual, what I have done in case 1 I'm going to do it in case 2, but the only thing is that instead of the vertical strip I am considering the horizontal strip in order to measure the total region that has been bounded by the circle. So the area of the horizontal strip, that is horizontal strip, area of the horizontal strip, which is nothing but x into dy, because area of a rectangle, we know that length into breadth. You have a length over here as x, you have a breadth over here as dy, so x into dy, which will be x into dy, x into dy. Okay, that is the area of the horizontal strip. Now what I'm going to do is that I am going to calculate the area of this region, area of the region, area of the region OABO, that is OABO, area of the region. What will be the area of the region? Which is nothing but this horizontal strip area is x into dy. Now I am going to find the area of this entire region, and this horizontal strip has the ability to move from this point O to the point B. So what I'm going to do is I'm going to integrate this one from 0 to A, 0 to the point A over here, right? So now what is the value of x over here? For that I'm going to consider the circle equation, x squared plus y squared equal to a squared. So what will be the value of x? X squared is equal to a squared minus y squared, or x equal to root of plus or minus root of a squared minus y squared. You got it? So since we are taking our operation, we are considering the first quadrant. In the first quadrant, all are positive. So since it is positive, I am taking only the positive sign, and I am removing or truncating the negative value. So my value will be, x value will be x equal to root of a squared minus y squared will be my x value. So I am going to take this value and I am going to substitute it over here, right? So what I'm going to do is, this value will be integral of 0 to a, x value is root of a squared minus y squared into dy. Okay, this is the expression and I'm going to integrate this expression. So what will happen? So again we know a formula, right? Integral tends from root of a squared minus y squared, which is nothing but y divided by 2 into root of a squared minus y squared plus a squared divided by 2 into sine inverse of y divided by a plus c. This is the formula that I'm going to use over here. So if I use this formula, what will happen? It will be y divided by 2 into root of a squared minus y squared plus a squared divided by 2 into sine inverse of y divided by a plus c, and I'm going to fix the limits 0 to a. I'm using this formula, and once I use this formula I am fixing the limits. So what will happen, the same thing is will be, okay, so it will be 0 to a, and I'm rubbing this one. So we got with this one. So now what I'm going to do is I'm going to substitute a in terms of y. for the first expression, and I'm going to subtract it with the another expression where I use 0 in terms of y. So for the first thing is, if I substitute a in terms of y, I'll be getting as a divided by 2 into root of a squared minus a squared plus a squared divided by 2 sine inverse of a by a minus, if I substitute 0 for y, 0 by 2 is infinity. Similarly, sine inverse of 0 by a is also 0 by a is infinity. So the second expression doesn't work out. It becomes void. So I'm leaving or truncating the second expression as such. So I'm considering the first expression. This is what I have obtained. Okay. So now, which is a squared minus a squared, which is 0. So I'm not considering this part. So I'm considering only this one. So that will be a squared divided by 2 sine inverse of a by a is 1. So again, a squared divided by 2 sine inverse of 1 is pi by 2, which is pi divided by 2. Therefore, the answer is pi into a squared by 4. That is for the region OABO. I am interested to find the entire region that has been enclosed by this circle. So since I have 4 quadrants over here, I am multiplying it by 4 in order to get the whole area that has been enclosed by the circle. So if I multiply 4 gets cancelled, the solution will be pi into a squared. So this is the solution for this one, right? Fine. So now this is what it's all about. Please do subscribe my channel. Thank you all.